Hey everyone, welcome back. Have you ever wondered how LinkedIn, one of the largest professional networks, handles tens of millions of API calls per second while keeping your data secure? Today we are diving deep into LinkedIn's sophisticated authorization architecture that ensures fast, secure, and scalable access control for its massive ecosystem. We start by the system design with the user. Everything starts with a user. The user sends a request and the request called the request to go through a Nuage server. Nuage is LinkedIn centralized management tool for handling ACL, and ACL is called it's access control list. It's the management thing for the ACL data. It provides a user-friendly interface to manage ACL entries, define who or what has access to specific resources, perform CRUD operations. CRUD is short for create, read, update, delete on ACL data. This tool ensures that developers or system administrators can easily update and maintain authorization rule without directly interacting with database or caches. Next, we have the ACL service by itself. And I would like to give it a background here. Let's make it like this component allows the creation, updating, and deletion of ACL entries. When any change is made to ACL data through the Nuage service, these operations ensure that the updates are passed to the backend systems, especially that ACL service and the Espresso DB for constancy and availability. The next thing we want to talk about is first the we have the cache. We have a lot of things that will be connected with the ACL service. One of the things will be the cache, and let's change its color, make it black. And we have the um, the couch database as well. Pop, 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 pop. What we call it? The couch database, or we can call it Espresso DB. Let's make it bigger. And no. Yeah, we create. And the Espresso DB is connected with CDC processors. Let's give it a different color here, and let's give it a greenish color, black. And this one will send the request back to the ACL, but I guess I need to give this a different color so to be easier for us to detect what's going on. So we have the couch database. Like couch database is used as a high speed, low latency here in the cache. We call this one a couch database. It's for ACL data. Its purpose to store frequently access ACL data to reduce the load on the backend database, ensure fast access to authorization rules for real-time checks. Using a cache significantly improves the performance of authorization checks by minimizing database queries. And we have here the CDC process, or change data capture, CDC, change data capture. The CDC process ensure cache consistency by monitoring changes in the Espresso DB whenever ACL data is updated. The CDC process captures the changes in real time, notifies the Couch database cache to invalidate and update the relevant entries. This process guarantees that the cache reflects the latest state of the ACL data, maintaining accuracy across systems. And we have here the Espresso data. Espresso is LinkedIn distributed. Espresso is LinkedIn distributed NoSQL database used for storing ACL data reliably and at scale. It provides one, strong consistency for ACL records; two, high availability for read and write operations; three, scalability to handle the massive volume of ACL entries required for LinkedIn services. The next thing we have what we call, let put this one here, and let's make it like that. And if I guess we need to make it like as well green. And yeah, let's give them each one a color so it will be easier for us to detect what's what. The next thing we have that which is a sixth step. The step number 6 will be, let's put this one here, will be the auth client. Let's change the colors. The auth client is a lightweight module integrated into every LinkedIn service. Its responsibility includes first fetching the necessary ACL data from the Couch database, the Couchbase Cache database from the cache, or the ACL service by itself, performing in-memory authorization checks to minimize latency, logging every authorization check for auditing and monitoring purposes. And the next thing we have, it's a lightweight that is connected with a service. Let's make the server quite yeah. Let's give it a different color because we need to. And it will be, yeah, I will call service by itself. So the service refers to basically any LinkedIn microservice that requires authorization checks for every incoming request. The service uses the auth client to verify access permission against the ACL data. If access is granted, the request processed, otherwise it's denied, or the request is accepted, otherwise it's denied. And this service is connected with Kafka service. Why it's always go that small? I don't like that. So the Kafka servers, the Kafka serves as a messaging system that propagates events related to ACL changes or access locks. Key rules of Kafka includes distributing ACL change notifications to services relying on real-time updates, handling large volumes of log data guaranteed by authorization checks. I guess next we have the Kafka is connected with a inGraphs monitoring. Okay, that's great. That's a great. So inGraphs is a LinkedIn monitoring tool which provides first real-time visualization and analysis of authorization checks. Number 2, insights into system performance, such as latency or error rates during ACL lookups. Number 3, a detailed audit trail for debugging or compliance purpose. So, and everything, and also it should be connected with the service by itself. No. It should be connected by the service by itself. And this one as well should be connected with the user. Yep. Okay, let's try to understand how the workflow is going. So first, the manage ACL data, like users or administrators manage the ACL via the Nuage service. After that, we have the ACL. There is a CRUD operation. The changes are performed on the ACL service and stored in the Espresso database. Save data. The second thing is the save data, like updates are synced with the Couch database cache via the CDC processor. Also, we have what we call fast authorization checks, like services use the auth client to fetch ACL data from the cache for in-memory checks. Number 5, we have lastly log and monitoring, like every authorization checks is logged and monitored using Kafka and inGraphs. By incoming these components, LinkedIn achieves a scalable and high performance and secure authorization system capabilities capable of handling tens of millions of APIs per second. So this is a system design of how LinkedIn authorized 10 million API call per second efficiently. Yeah, that's it for this video, and see you in the future.